Hello everybody. In today's video, we're going to do some hopefully simple Java crackme. I've decided to go for a Java crackme this time because technically Java should be simple to crack, but because they are Java crackmes, the people who create them, the authors of those crackmes, they employ all kinds of tricks to make them hard to crack. So despite appearing easy because you can easily decompile a Java crackme, they might not be because the code is just a mess and it's obfuscated or whatever. So there are plenty of crackmes here that are difficulty 3, 4, 5. Yeah, so they are really difficult. This is a scale between 1 and 6, and this scale is really steep. So 1 is easy, 2 is already, in my opinion, hard, and 3 is impossible for me, at least in the scope of a single video, and anything beyond that is a project that will take you days probably. If you're a normal person. Yeah, some people will put in the comments, no, I've done 4s and 5s and 6s and they were no problem. Yeah, of course. If you spend all your time with those crackmes. But in this video, we're going to do a hopefully simple crackme just for relaxation. So I've decided to go for this crappy code crackme. It's a Java crackme and I've already downloaded it to make sure it's executable. And we can execute the crackme.jar file using java-jar to invoke the JVM, the Java virtual machine that runs Java applications. And let's do java-jar crackme-jar. And now the application is executing. And we can enter a key. Just as a hint, if you want to do this on your machine, you have to install a Java JDK version 24 or higher, because this crackme.jar has been compiled with such a recent version. Yeah, so I've already done that. I have set up OpenJDK here, I've downloaded it and put it in my path variable. So when I do Java version, it's Java version 24. So make sure to use that if you want to follow this video. So the application prompts us to enter a key, and let's just enter some key. Let's say ghost, and it's telling us that's not correct. Obviously, what would the chance be? Or let's enter the key. Let's guess hexor. That's not correct. Or let's try another one, 1337, and it's not correct. Okay, so we can keep guessing or intelligently reverse engineer that crackme. And yeah, as most of you probably know, Java crackmes or Java files are so-called bytecode. They are not compiled to machine code, so therefore they are easier to read. But yeah, there might be some obfuscation in the file. And by the way, a .jar file is essentially an archive. It's as far as I know, even the same as a zip file. So we can even do unzip crackme.jar, and it's inflated, as you can see, the contents. And let me just remove all that OpenJDK mess here. And the log files. So we have the crackme.jar and we have extracted it using unzip because jars are essentially zip files. And as you can see, it contains some metadata and a .class file. And a .class file is a Java application that has been compiled to bytecode that runs in a virtual machine, in a Java virtual machine. If we do vim and inspect the crackme jar, you can see the exact same thing because vim can also traverse zip files. As you can see here, there's the hint zip.vim version v28 browsing zip file. Yeah, so if you see a .jar, always think in your head, this is a zip file, essentially. It just has a different name. And it's a zip file that contains Java stuff. So let's have a look at the meta.inf directory. It contains a file that's called manifest.mf, and that's just metadata. It was created with Java version 24.01. Oracle Corporation, maybe that's indicating that this was compiled with some Oracle provided JDK. I don't know. But this is definitely not important. The only important thing here is the main class, which indicates to us what the entry point to the program is. So if we had hundreds of .class files inside that .jar file, then we would look here, see the main class is main. And then we could see that, okay, we have this main file here, and this is our entry point. In our case, we have just one single file, but if we had a ton of files, then this would be quite a useful pointer. Alternatively, we could probably also do a grep for main and get some result. In this case, we don't get a result even. Of course we don't get a result because we are dealing with bytecode. So let's inspect the main.class file. And as you can see, we can read some of the content of this file, especially the names of the classes and objects being used. We have an input stream, we have sprint streams for in and out, and the scanner, which is also, I think this is like the scanf in C, which is just reading the standard input. Then we have a random import here, which is indicating that there might be a random number generator involved. Next int is reading stuff from something. Then we have the alphabet somehow here, which might be hinting at something. We have a couple of oddly long CCCCC, etc. strings here. And then we have a bunch of just dumped binary data, it looks like to me. This looks like dumped hexadecimal stuff, 6061. Maybe those are ASCII characters. I don't know. We can't really tell if we're not bytecode gurus, but this looks like an enumeration of some alphabet here, of some character set. I might be completely wrong. So let's exit that. And now the question is effectively, where can we go from here? And I would suggest we just pick a Java decompiler right away to save us the hassle. We could probably import this jar file somehow in an IDE and decompile it there. But as far as I know, there's a Java decompiler, which we can use straight away. It's a small graphical user interface. We can download it here, and it's also a Java application, as you can see, .jar. And it's quite funny that you can decompile Java with Java. Well, obviously, yes, it's true that this is possible, but somehow it's funny to me. So it's now downloaded, JD GUI-166.jar. And let's just rename it to give it some more concise name, Java decompiler.jar, and let's Java jar JD jar. And as you can see, something is starting now, and it's popped up here. And I can now open the file crackme.jar, open that and click on that class file, and it has decompiled a result. Oh, we can even zoom in. That's nice. I would suggest now, because that's already decompiled result, that we don't even need the decompiler anymore. We can just copy that, close the application, and create a file, main.java, and paste in the decompiled code here. And that's it. And now we can inspect it in our console. And we can even probably run this Java, this decompiled Java, in our terminal and see if it resembles the same behavior as the original .class file. So let's check java run.java file, if that's possible. We have to compile this first. Yeah, so let me rename this to main. Let me rename the main.java, which we have just decompiled, to make it more explicit, to decompiled.java. And now we can java compile decompiled Java. Oh, and it's missing imports, it seems. Expected import. Wait, is anything wrong in the decompiled Java? Ah, yes, I forgot an I. This is a paste error. This happens sometimes when I copy paste stuff, then the first character is omitted because some intricacies of Vim. So let's try to compile the decompiled again. And it's done something. It contains errors. Yeah, incompatible types Boolean cannot be converted to int. So it seems that the decompiled Java file is not compilable, at least not without changes. Let's see why. Error class main is public, should be declared in a file named main.java. Ah, of course. Yeah, the issue is that the file that the class file that I'm trying to compile is called decompiled Java, but it contains a class that is not called decompiled. So we can work around that. Let me just rename it to decompiled.java again. And let's go into the main class and rename it to decompiled. Because in Java, the class name has to be aligned with the file name. And now we can probably, hopefully, compile it. javac decompiled.java, and it doesn't work. Because of incompatible types, Boolean cannot be converted to int. In line 38. So let's go to line 38. It's this line. Wait. But what's the issue here? Wait, what is my Java-C version even? 24. Okay. Some messages have been simplified. Recompile with x-diex verbose to get full output. Incompatible types, Boolean cannot be converted to int. Well, we can technically do open Eclipse which is a Java IDE. Let's launch it. Okay. And then I can probably just copy that decompiled Java file into Eclipse. I hope it loads. Yes, it does. And there we go. This is an old project that I did here. I can just delete that. I don't need it. And oh my god, ads are popping up. Eclipse Foundation ads. And let's just try to move the decompile.java inside here and see if it highlights any issues with this. Let's create a Java project, maybe decompiled. So, and there's a source directory, and the source directory can contain our decompile.java. Copy file into this. And yes, there are a couple of issues. So what does the Eclipse IDE tell us? String cannot be resolved to a type. The import contains only Java IO. But string does, wait, do we have to import Java dot? Wait, no. Java string is part of Java lang. Isn't that already imported by default? I don't think I need to import strings. Let me just also enable word wrap. Where is it? Search. No, it's not there. Okay, but what are the errors here? I don't get it. Maybe because I don't have a package here. Package. Yeah, I don't even know if I need a package, honestly. All right. Anyways, I don't want to waste time here in this IDE. I hate IDEs. Oh, I don't. But I prefer to use this terminal in this video. So let's have a look at the decompiled Java file and see what we can do here. It's really a mess. And what this is doing, what this executable is doing is it's what is it doing? It's printing out a string, and that string is string 3. So that's maybe the first hint, string 3. Okay. And string 3. There are a couple of characters here. Okay, I get it. So we have these strings here, and They are constructed by calling the alphabet here and then character at B12, for example. And B12 is a variable, and B12 has the value 19. Yeah. So probably what we can do is, well, what we should do is we should simplify all of this. I'm just not sure to which degree. So what is the simplest way to get to our goal? Okay, I'll do the following. Let's go into the crackme directory. There it is. Java jar crackme.jar. It's asking to enter the key. We enter some key and then it tells us that's not correct. So some printout statement somewhere here prints that's not correct. Yeah, essentially this code is just a mess. I'm just thinking of what is the most efficient way to bring some order to this. Let's do the following. Let's rename now. I was thinking about renaming B1 to just 4 or something, but this is also not feasible because if I replace all the B1s, then this will also affect the B19s, the first 2 letters here. So, but I also don't want to manually dig through all of this. What a waste of time. We could use a debugger. Yes, we could use a debugger. And because we have decompiled the Java executable, if we can just make it compilable, then that would save us so much headache. Because in a debugger, we could step through all those lines of code and then we could see what the values of those strings are. So Eclipse is probably the best debugger for now. There's also a command line debugger that we could use that's called JDB, but that one is, yeah, not very simple to use. Okay, so what we must do is we must fix up the decompiled source code such that we can run it. So let's give the package a name. And maybe I should increase the font size. Colors and fonts. Is that possible? No idea. Okay. Then let me delete the decompiled. There's the default package, or maybe let's create a package. Let's call it package decompiled. And inside that, let's create a class file that's called decompiled. And then we can paste all the source code and also reference the package decompiled up here. Oops. So now we should be able to somehow get some useful hints here, down here in the error log, about what's wrong with this executable. Let's delete all the events. Maybe let's open the problems tab. And there are build path errors. Let's check the properties, build path, and we have to reference a JRE, which was somehow not referenced. And let's apply and close and see if that makes a difference. Maybe the issue is that I don't even have Java installed on my system. Wait, Java build path? I should have Java installed. JREs, let's get the 19 one. Apply and close. Project clean. Let's clean the project. And I see this error here, unbound class path container in project. Unbound class path container error in Eclipse. An unbounded class path container for an Eclipse project implies that the JRE associated with the project is not available in the list of JREs available in the workspace. You will need to modify your Java build path, accessible via project preferences, to use a JRE version that is valid in your workspace. Okay. Aha, I understand. What Eclipse version am I even using here? Okay, so I can't use this JRE here, I think. I have to use some existing one, and this one is not an existing one, apparently. I have this JRE installed. JRE is, by the way, runtime environment, so we're dealing just with referencing executables here. Can I add a JRE? No, let's clean up my Eclipse installation completely, and let's also, I will go a bit privately now in my users directory and delete my Eclipse workspace because it's probably messed up because I used different Eclipse versions in the past. And let's restart Eclipse. So maybe it's just a local issue on my side. Because when I first started Eclipse in this video, it told me that this Eclipse workspace is corrupted because I already used it with a newer version of Eclipse. And now somehow my Eclipse looks fine again and we have dark mode enabled. Yeah, so maybe this was, it looks weird. Okay, let's create a Java project and let's call the project Decompiled. That's weird dark mode, by the way. But okay. Now we have a JRE here, version 17, and that's probably good enough. Let's create a package just to make it nice, decompiled. And now it's time to get the Java file, decompiled.java, and let's copy that into our Eclipse instance. And now here we have to, of course, also reference the package package decompiled. And it looks all fine. I don't like the color scheme. It looks somehow toxic. So let's do classic Eclipse again. Yeah, let's restart Eclipse again. What a back and forth episode today. But I think we're approaching the end already. Java is always a lot of setup, and you have to set up your stuff. But once it's set up, it's a simple language actually. As always, simple is not easy, but you can get around quite easily. Well, not quite easily, but you can find yourself. You can find your way around because the Java ecosystem is awesome. So we just now see the exact same issues here. Those small flags indicate that there are issues with those lines of code here, as our Java compiler in the command line already hinted. So let's hover and see what the issue is. The method character at in the type string is not applicable for the arguments. And there's the argument bool1, and this is false. There are a couple of booleans that are used to access a character here. And those might not be... Well, this might be a wrong decompilation. I don't know. The booleans could also be just the value 0 or 1. Who knows? But what I would do is I was thinking about just deleting those lines of code. And not the lines of code, but those accesses. Yeah, so let's try to delete everything that contains the bool accesses. And then see what happens when we run the system and debug it. So maybe we can get already a partial result, even if it's not a full result. I don't know, because it depends on what is contained in those strings here. Oops. Okay, and now we have a hopefully working executable, or a hopefully working piece of code. So let's see what happens if we run this in a debugger and we put the debug breakpoint right at the scanner, which is prompting us to pass in something using system_in. So let's debug this as a Java application, and let's go. And there we go. So now we can inspect the values of string 1, 2, 3, 4, 5, 6, 7. And let's see what string 1 is. String 1 is int ecke. What? String 2? Titso sno correct. That looks like this is not correct. That's not correct. That's not correct. Somehow they are jumbled up, garbled up, garbled up. Correct? Where? What? Extra. Somehow the A's are missing. Maybe the A's are the things that I deleted. Congrats. Probably. FFH. What? Okay, let's go to the next line. Enter. No, this can't be. If string 8. String 8 is what we input. Equals string 4. String 4 is, this is probably the password, but it's garbled up somehow. And I wonder why it is. What's the point of I, J, K, M, and N? Are they even used? No, wait, let's stop the debugging. The value of the local variable j is not used. Wait, let's undo all the changes that we did. So, okay, now this is the pure decompiled code. Now, which variables are not used? Problems. And now it doesn't tell me that any variables are not used. Why? Where is I used? It's not used anywhere, is it? What happens if I format the code? Does it help us? Maybe a bit. Okay, so this is now the same code. It's still the original code, but it's formatted. The character add boolean. Those are the confusing things. Maybe it makes sense to check with a different debugger if they also tell us that booleans are used here. Maybe it gives us a different result. Wait, Java decompiler online. Here we can drop a file. Let's put the crackme.jar here and upload and decompile, and let's see what the result is. There's a main.java file. The content was hidden by advertisement filtering. Okay, okay. Here, get my $0.50 for viewing your ads. Okay, there are variables here. And then there are the character add accesses here. But there are no booleans. Or are there? Where are the booleans? Oh, there are some booleans and they are all true. Variable 95. Okay. Okay, let's check where variable 95 is used. Nowhere. That's weird. What about variable 96? Not used anywhere as well. Or either. Yeah, they are not used anywhere. But then why do they decompile to true? Maybe they just have the value 1. I feel a bit stupid right now because this looks like it should be simple, but it's very confusing to me. So we have all these bytes and they are just numbers. And then we have the booleans and they are false in my case. Why does the other decompiler say they are true? Maybe because they are not used. But here they are used in the character at accesses. You know what? We don't need to decompile and recompile it and debug it. We can use JDB. I mean, it's hard, but we can use it. The only thing that I want to use, because JDB is horrible to use in the command line, because I can't, when you type something, then you can't use Control P, you can't use Control N to get the next, the previous commands you entered and stuff like that. I think there was a utility that you can use with that, JDB. Debugging with JDB command line tool. I think it was called something like line wrap or something. Wrapped in RL wrap. RL wrap. Yeah, I need that one. Git clone, RL wrap. It's not already installed on my system, is it? Oh, no, but it's installable, so I don't need to make it myself. And to everybody who's not familiar, RLWrap is a readline wrapper. It's a small utility that uses the GNU readline library to allow the editing of keyboard input for any command. Yeah, it just makes using something more natural. So I can do rlwrap jdb. Yeah, and now I can type some command, and then I can call Control P and just pull that same command up again. So basically it's for convenience, because many applications provide that out of the box, but JDB doesn't because it's so old, and it just doesn't. So we call JDB with the input crackme.jar. And let's check the help. And we want to put a where do we put a breakpoint if JDB doesn't know the source? We have to provide the source, I guess. Source. What if I do list? Yeah, doesn't work. Class path. Monitor. Or another variant would be another thing that we could do, because JDB is a bit confusing if you don't have the original source code. I don't know if I can just give it different source code, the decompiled source code. What if I do classes? Run? Nah. No, that's not a good solution. I think I have installed under software. No, I don't have it. What was it called? Visual VM. That's a tool that allows us to inspect a running Java application. So let's try. Let's cd into the software directory, wget jvisualvm. Let's unzip that, visual VM. And then we can do visual VM. Let's do that in this bottom right pane. Software, visual VM, bin. And then let's open visual VM. And yes, there's now a graphical user interface again. This is a really powerful tool, guys. You can do everything with Visual VM. You can dump your entire application's memory. If you don't know what you're doing and you have a confidential applications where users enter their passwords, those dumps will contain the passwords. I have had that before. You can inspect threads. You can inspect this is basically like a watchtower for everything that happens in your Java applications. It's awesome. I wish I would spend more time with it. So maybe we can make use of it. And now in the crackme directory, let's execute java jar crackme. And we can execute that because according to the source code here, we know that all those strings are calculated. And then only after that, the scanner is called. And then this equals test is being made here. So because we're now stuck at this scan statement, all those strings should already reside in memory. And maybe we can inspect that using the crackme, using jvisualvm. And as you can see here, we have a running jar file, crackme jar, and let's double click on that. And as you can see, we can monitor that. It's using some memory. We can see the threads that are running, and we can sample the memory, and we can profile stuff. And I think if we sample the memory, that's already good. So let's click on sample memory, then stop. And now we have all the objects in memory. And as you can see, there's a ton of stuff here. And there are Java strings here. Can we go? What happens when we go to source? No. Source roots. Can we add something here? Crackme. Choose password for new keyring? What? Okay, I'll just do it. I trust you, jvisualvm. Copy live objects, what's that? Can I now, wait, I have just copied something. What if I, no, that's just the number of objects. We have 64,000 strings in memory. Perform heap dump. And there are all of our strings in here. As you can see, there's the object type, string. Then they are indexed using number 1, number 2, number 3, etc. And then there's the name of the string. I don't know if that's the clear text of the string. I think it is. Let's just scroll through those strings. I'm not sure. Hierarchy. Basically, all that I need to do is, or all I have to do is, I need to find the strings, those strings in memory. It can't be that hard. If you remember Cheat Engine, which is an application from, well, many years ago, you could basically find anything in memory. That was awesome. And even change it. So we have this heap dump here. And we have strings. And the string has a value. And it looks like the value is precisely what is written here next to the string. So technically we could just scroll through all of this. Maybe let's have a look at the last string instances. Oh, they look like languages. Thai, Latin. But maybe the last string instances are the last strings on the heap. Oh, and there's something. There's the hint. This is the garbage collector root Java frame, and it says enter the key, which is this string right here. Okay. Let's see. Can we find the key? There's something here. This looks suspicious, but I don't know if that's the key. I don't think so. Garbage collector root. What is the garbage collector root again? GC root Java. What is it? GC root, garbage collector root, is a term used in the context of garbage collection in Java. It's an object that is accessible from outside the heap. They are special objects for the garbage collector. They are starting points for the garbage collector processes. In general, all objects directly or indirectly referenced from a GC root are not garbage collected. Okay, and now the garbage collector is referencing this right away because this is in memory right now. And anything referenced by the string is not garbage collected. Still, I need to know the password. Just give me the password. I don't want anything else from you guys, or from this from this challenge here. There's the main.class string. There's the file path. Those are probably the arguments. There's the manifest. It looks like anything above that here. Oh, this is already beyond our jar file. I hope you can read this, because this is really full screen. Oh no. Oh no, now it's on a different screen. Oh no. Wait. There it is back. Customize. Oh no. Okay, let's not mess this up. The password must be somewhere here. I just wonder, wait, can we filter? No, we can't. What happens if I search for the strings somehow? Can I search the strings? And there are really a lot of strings for this small application. I'm now a bit confused. Where did my object go? I mean the string that we just found. In any case, this heap dump, we can probably save it. Let's save it in the crackme as the heap dump. And then maybe we can search the heap dump. So let's do heap dump hprof, and then let's search for enter the key. Enter the key. And there it is. It's the last string. Can we find anything else? Enter the key. Ah, it's not, maybe not the last string, it's just here. There it is. Java heap dump analyzer. Memory analyzer in Eclipse, yes. JProfiler. Eclipse memory analyzer. Is it already installed? No, I don't think so. No. Technically, we should easily be able to see the string in JVisualVM according to my best understanding. So this is the heap dump. We can go to objects. Then there are a ton of strings here. We can, what if we filter? No, doesn't give us any good results. What if we do, well, let's have a look at the source code for one more second. This is the scanner. This is the string. All of this is a string. So the information we need is stored in a string without question. Yeah, so we have to open a new tab, the strings. Then what does hierarchy do? This is the class inheritance hierarchy. Okay. Then we can scroll down, go to the last instances here. Or those ones. And if we scroll to the very bottom, then we can see somewhere. Oh, there's even the A, B, C, D, F, G, H, the alphabet string. There's the enter the key. And now what is the key? What is the key? Enter the key should be this string 1. Enter the key is string 1. That means that string 4 is the input and string 4 comes after string 1. So I would expect it in the heap dump to be after enter the key. I don't know what those keys here are. Or that one, or that one. But what's this one? String 4, string concat. String 4 looks fairly simple. Actually, oh god. Actually, we could just figure this one out ourselves probably. But still, where is it here? Why is it not here? Invoke special. How many characters is string 4? 1, 2, 3, 4, 5, 6, 7. Yeah, 7 characters. It should be 7 characters. And then we check if string 8 equals string 4. Seven characters. And they should all be lowercase alphabet characters. Reinvoke. What about reinvoke? Reinvoke. That's not correct. Reinvoke special. That's not correct. Yeah, educated guess, just because this is in the heap dump invoke special. I'm a bit lost. But let's do it the hard way. Let's figure out what string 4 is. So let me do the following. String 4 is here. Character at B55. B55 is 19. So character 19 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 14, 15, 16, 17, 18, 19. S. Starts with S. Is there anything that starts with S here? C to offset. Number to alphabet. So input number 19, 2 letter is S. Good. Then character at B55 again, 19. So we have S, S. Then character at B56 is 3, ABC, SSC. B57 is 5, ABCDE. And then B57, no, we already had that one. B58 is 4, SSCED. And B59 is 8, SSCEDH. And B60 is 17, SSCEDHQ. Is that the password? Wait, let's try again. SSCEDHQ. No, that's not correct. But maybe we can search for that string in the heap dump. SSCEDHQ. It's not found. Wait, that cannot be. Or can it? Well, of course it can be, because the technology is never wrong. And it's more likely that I'm messing up something. But what? I think I'm stupid, guys. Wait, where's my Eclipse? Wait, I have to close that. I think I'm stupid because if we access character at B55, then this is 19, but we can't just use, why am I so stupid? If I convert numbers to letters like this, of course this will result in this output, and it makes sense, but we are returning the character at an index here. So A is not the first character of the alphabet, it's the 0th. So what we have to actually have to input here is 2020 4 6 5 9 7 18. So we have to offset this by 1. TTD FEIR. What happens if I search the heap dump for that? Not found. I don't get it, but I would bet that because our code is checking exactly that. Where is my... I don't get why I can't open Eclipse normally anymore. Right here. We are checking string 4. If string 8, our input equals string 4, then we proceed with something. Maybe the JVM is somehow optimizing this because we are scanning the line here. And the JVM knows that string 4 is only needed in the next line. So it computes string 4 only later. Who knows? I don't know. And this could explain why it's not in the heap dump. But let's try to enter this as a key. TTD-FEIR. TTD-FEIR. That's not correct. TTD-FEIR. So how can we get the solution here? This is ridiculous. String 4 seems to be the only string that's really used. String 3 is being printed. It's telling us something, but we don't really need it. Well, what strings contain errors? String 2 contains some errors, so we can just... Let's write string 2 here. I don't care. I don't care about breaking the code now. String 3 contains something. String 3 contains something. String 5 contains an error. And string 6 contains an error. So what happens if we run this? Then now we can inspect the value of string 4 and it's TTD-FEIR. What about string 7? FFH-IIF. Okay, let's see what happens if we step through the code. Enter the... I don't get why string 8 is messed up here, and it's not messed up in the terminal. Why is what's going on here? String 7. Enter the key. No. String 8 is enter the key. No, wait, I'm confused. String 1 is enter the key. But why is it messed up? Is it just decompiled wrongly? Well, it could be that because this code is such a mess that it's decompiled wrongly. Why not? So here, variable 120 is checked if it equals 115. 120 is our input via next line. And 115 is this variable 1000. This is character at var1 at 4. Wait, so this is 4, 0, 1, 2, 3, 4 E. So here, this starts with an E. E, var 60 is a 3. D, so this is a D. Let me just note that down somewhere. ED. Ah, no, variable 1000 is, or 10,000 is reassigned right before 115. This is character at var 59. What is var 59? 19. So this is the letter T. So we have T here, then variable 60 is this is ridiculous. What the hell am I doing? There must be an automated way to do this. Variable 60 is 3, A, B, C, D. So we have T and D. Then we continue with variable 61, which is a 5. 1, 2, 3, 4, 5, 6, TDF. Variable 62 is a 4. And E, TDFE. Let's search for TDFE here. TDFE. Oh, but here we previously searched for TTDFEIR. Is it maybe just TDFEIR? No. Why was I thinking that it's TTD? Variable 1000, character, blah, blah, blah. It's ridiculous. This is ridiculous. Let me just copy all of that and put it in the debugger. Let's see if it can do anything with this generated file. contains problems right here. Right in the variable that we need. Cannot convert from int to string. Change type of variable 115 to int. No, why? Why does this think that 115 should be an integer? Maybe one thing that's also apparent is that those variables are all called in order. So variable 67 is before 68, is before 69, is before 70, etc. So we could technically also just decipher all of those. I just don't want to do it manually because it's annoying. The package name is decompiled. And the class name is decompiled as well. So, what if I delete all of this? What is variable 10,000? It's the alphabet's character add something. Variable 1000 is a character. What if I do this? This somehow works. Okay. This is such a displeasing episode. There's so much stupid, unnecessary making our lives hard in this episode. So let's put a breakpoint here and see what we can do. Now it output 542 the key instead of enter the key, which is of course wrong. No, something is wrong even with the decompilation. Let me put a breakpoint here, then run. Again, let's try again. Now we have reached the breakpoint. And I don't know why it says 542 the key now. So somehow the decompilations are just wrong. And variable 115 is tdfeirg. Okay. Correct So this one was somehow correctly decompiled. So this is really the correct password. Where do you want to extract the file? Is this also some challenge, or let me just call it result.txt. An error occurred. Okay, so it seems that we have the password, and the password or the key is tdf EIRG. Okay. And then let's input it here as well, tdf EIRG. And let's step through the debugger. It outputs correct. For whatever reason, it outputs 754 here, no idea. It must have to do with the decompilation, which is somehow this program is so messy, or was, no idea that this is the result here. So it asks us where we want to extract the file. And then something happens. It tries to construct a new file using variable 121. Let's try to see the value of that. That is our input string, and variable 116, which is 865.txt, and that is probably wrong. Here the decompilation is probably wrong. 865 is probably broken for the same reason. 542 and 754 are broken as well. But it looks like this is the start of a path that we have to enter, and this is the rest of the path in a text. This is the actual file name. So probably we can just pass the current directory using a dot. No. tdf EIRG here. No. And the file writer writes to variable 117 regardless of what. No. No, the file writer writes the content of the string 117. Blah blah blah, you get it. To a file that is called 122, and 122 is this. Okay, let's try to step into this. Let's write here, and now let's have the file constructed, and let's see what the file is. It's here, 865.txt, and then this file writer is opened. The file writer writes and closes, and it tries to create a new file, and somehow an error occurs. Why? No idea. File path status checked. I think we have to find out the name this file writer is supposed to write to. So we cannot freely name it. We must name it something something. And then this must be the ending, although the 865 is probably wrong. Variable 116. What if I do a search for .txt? Congrats.txt is in the heap dump. Congrats.txt. So we must have a file that is called congrats.txt. Congrats.txt. No contents. And then let's execute the crackme. Let's pass the password, the key, and then let's not input any string here and just write to congrats.txt, and it doesn't work. Why? Oh no, it worked. It has output congrats, you get it. But why did it output an error occurred? It tries to create a new file. Huh? So it creates, wait, no, it creates a new file. Then what's the... Why does an error occur? Okay, no, let's try again. Let's remove congrats.txt. So we can execute the crackme, we can input the key. Correct. Now let's not input a file to be extracted. And it says an error occurred, but we have a new file that's called congrats.txt. And it tells me, congrats, you get it. So somehow we have failed successfully. What if I call it Daniel? An error occurred. No. It tries to create a new file. Why does create new file not return successfully? Returns true if the name file does not exist and was successfully created. False if the file already exists. So we can freely name our file, technically. Maybe because the file writer is open here somehow, I don't know. Maybe I have to terminate this. Maybe they are interfering, the JVMs. So let's try again. The key. Let's say we want to extract to Daniel. No. Let's remove the congrats file again. It's removed. Huh? Now it has extracted to Daniel congrats, so that has worked. So wait, now we have I didn't catch that it created all those files. Now we have removed all the result files. Let's try to execute the crackme, enter the key. Correct. Where do you want to extract the file? Let's say here. It tells me some error occurred, I don't know, but the file is successfully created and we can read it. Less here, congrats, and it tells me congrats, you get it. Congrats. Huh. So for some magic reason, create a new file returns false, but the named file does not exist. Maybe this is some intricacy of the JVM that I'm using right now. I don't know. Let's have a look here. Create new file. Atomically creates a new empty file named by this abstract path name if and only if a file with this name does not yet exist. Returns true if the name file does not exist and was successfully created. False if the named file already exists. Maybe this is the error that is happening. I don't know. Let's try to debug this again. I will put a breakpoint here and here. I know, but if this was the error, then we would have a printout of the stack trace as well. So somehow the printout is an error occurred, but a file was created, so there's no issue. Wait, a file is created and the file is called variable122. Then a file writer is created and it's called variable123. Then the content of variable117 is written using the file writer 123. And then the file writer closes, and then 1 to 2, the file is created, but the file writer already created that file. So I would consider that this is somehow duplicated behavior. The file writer creates the file by writing stuff to the file. And then the file somehow creates a new file. What sense does that make? In Linux, it's definitely the case that if you write stuff to a file, the file is created. I don't know if that's different on any other system. Yeah, but I would say this is a wrap up. We have solved this crackme. It was a weird journey. Somehow this crackme was really unpleasant, but I'm proud that we endured it, and we have looked at so many different aspects of the Java ecosystem. We have looked at jar files, at decompiling them, at Eclipse, running a decompiled file even though it's broken. And we have fixed it and managed to get some partial stuff in memory from the debugger. Then we have used JVisualVM to create heap dumps and analyze everything that is in memory. And we have done a ton. So this was really insightful, and we have solved this crackme. This right here is the key. So let's input it, and it tells us correct. Where do you want to extract the file? Let's say Daniel. It tells us, it wrongly tells us an error occurred, but it's created a file, and the file contains the congratulations that we did it. That's awesome. We did so much different stuff here. I just want to see if the password is also part of the heap dump, and yes, it is right here. So we could have also found it if we had somehow had better clues looking and studying the heap dump, All right. So again, we have cracked the crackme. This is the key. And as a gift, we get a congratulations file at the end with this printout. That's it. I hope you enjoyed it. And this was a lot of work for me, especially after work. And now it's night. It's nighttime, and I have to go to sleep and wake up early and immediately work again. Please stick around and leave a like and subscribe, and see you next time. Bye.